All right, so in the last section here of chapter 14, we're going to be taking a look at the second functional group that contains nitrogen in them, and that is the amides or amides. All right, so you can pronounce that a couple different ways. And the amides are going to look similar to another functional group that we saw previously. They're going to look similar to the carboxylic acids, right? So if you remember, with the carboxylic acids, we had a C double bond O connected to an OH. In an amide now, what we're going to have is we're still going to have that C double bond O, but now instead of that OH, we're going to have a bond to nitrogen. All right, so that's the main difference here between a carboxylic acid and an amide, and it would make sense, as we're going to see in a second, because you actually can make an amide from a carboxylic acid. So the way that amides are made is by a process called amidation, just like the way that, or the process by which an ester was made was called an esterification. So amides are made by reacting a carboxylic acid, and we're going to combine that now with either ammonia or either a primary or a secondary amine, and we're going to need a little bit of help with some heat to get that reaction happening. All right, so just like when we looked at the esterification reactions, we're going to see some parallels here with the formation of amides. There's our carboxylic acid with the carboxyl group, and here now we have our ammonia, and specifically the part of ammonia that we're going to be concerned with is that H, all right, which is right here. So what's going to happen is the OH from the carboxylic acid is going to combine with an H, either from an ammonia or a primary or secondary amine, and those two things combine to make water, right? We have H and we have OH. So water is produced, and then we end up making a brand new bond now between that carbon of the carbonyl and that nitrogen. All right, so this is the new bond that we make here. And that really is the center part of our amide bond, right? So the amide bond is this. And we're just linking together the carboxylic acid with that nitrogen and then whatever else that nitrogen is attached to. So if we take a look at a slightly different reaction with methylamine, this is a primary amine, right? Meaning that it's connected to just one other carbon atom. Here again, we're going to lose water as one of the byproducts of this reaction. There's our H2O. And then we're just linking now this carbon here with that nitrogen. All right, and there's our amide bond. The new bond that we make. All right, and that's at the center of the amide functional group. So let's take a look now how we can practice that. So we have the two molecules. We have a molecule here on the left that has our carboxylic acid functional group, and then we have a nitrogen containing amine here on the right side. So when you have this type of a reaction, just like as we saw with the esters, you want to redraw or rewrite the reactant so that the reacting parts of the molecules are closer together. All right, so what I would do is, if this is my carboxylic acid and this is benzoic acid, if you remember, and I'm going to react that now with, I'm going to just redraw my amine, so I have an N connected to a CH3, and then I also have two hydrogens attached to that nitrogen, right? So I've redrawn it in a way that makes a little bit more sense visually, and now I can apply the same things that I saw previously. So my H and OH, they're going to combine. All right, so we're going to end up making water as one of the byproducts. It's not the most important product. The amide is, right? And we're going to be making now a new bond between the carbon and that nitrogen. So again, a good way to start drawing the product is to draw everything that doesn't change first. So I have my benzene ring. I didn't mess with that. I have my C double bond O, that's still there. And now the new bond I'm going to make is a bond between that carbonyl carbon and that nitrogen from the amine. That nitrogen has attached to it a CH3 and another H. Right, so that is my amide bond here circled in red, and then in green here, that's the new bond that we created. Right, and that's essentially what's happening in all of your amide reactions, just like we saw with the esters. When we make our amides, we need to address how we name them. All right, and in both the IUPAC, the systematic way, and the common naming system, the amides are all going to end in AMIDE. All right, so that's a really quick clue to tell you that you're dealing with an amide, and we get that by dropping the oic acid from the carboxylic acid, and then we're going to replace that ending with amide as the last name. And then the other thing that we need to address is if the amine that we used to make the amide had carbons connected to that nitrogen, well then we also need to address that in the name. We're going to write that prefix N. We saw this with the amine nomenclature in the previous section, followed by whatever the alkyl group was attached to that nitrogen from the amine. All right, so if we go back up here to the example that we just drew, all right, the acid that we used to make here, I'm just going to highlight our amide. We're going to name this systematically. All right, we used, the acid here was benzoic acid. So as a last name now, as an amide, that would become benzamide. All right, we're dropping the oic acid. We replace it with amide. And then if you look at the nitrogen here, it's attached to a methyl group. All right, so then this would be N-methyl. And then we're going to stick that in front of the last name, benzamide. All right, so the name then for this entire thing would be N-methyl benzamide. Right, and that tells you everything you need to know about that structure. So if we take a look at the structure down here on the bottom, all right, if you have to name it, again, you want to identify the functional group present, and in this case, there's our C double bond ON, right, that tells you that it's an amide. To identify the carboxylic acid, you find your C double bond O, right, because that's where the carboxylic acid would have come from. We have a 1, 2, 3, 4 carbon carboxylic acid, right, so that would be butanoic acid that it came from. So as a last name then, we would name that as, if we have butanoic acid, all right, we drop the ending oic acid and we replace it with amide. So it becomes butanamide. And then on the other side of the molecule now, we have two methyl groups attached to that nitrogen. So then that would be NN dimethyl. That takes care of those. And then we insert that in front of the ending, butanamide. All right, so again, we use a systematic way to address the nomenclature of the amide. All right, so let's take a quick look here at, let's do B down here on the bottom. Actually, we'll do both A and B. All right, so in A, right? Again, identify your amide bond. There it is. All right, so the ending here would have come from whatever the carboxylic acid was, and we'll highlight that in yellow, right? The C double bond O, the carbonyl, tells you what part of the molecule came from the acid, and we have a 1,2 carbon carboxylic acid, so that would be ethanoic acid. And then as an amide, this would become then, drop the oic acid, replace it with amide, so ethanamide. And then on the nitrogen here, we don't have any other carbons attached to it, so that'll be the only name for this thing, or the proper name for it. It'll just be ethanamide, or the common name for this would be acetamide, right? Because it would have come from acetic acid as the common name. We'll just write that on top, common. And the one underneath, right, we'll do the same thing. We identify the amide bond, so here it is. Find the C double bond O, tells you that that part of the molecule came from the carboxylic acid. We have 1, 2, 3 carbons. All right, so then that would be it would have come from propanoic acid. So as an amide then, this would be called propanamide. And then on the other side of it, all right, if you notice here, we have also attached to that nitrogen, we have an ethyl group. All right, so that would be an N-ethyl. Even though it's drawn in a condensed form, it looks like an H here. That's bonded to two different things. Remember, that H is actually attached there, and then you have your ethyl group attached on the other side. All right, so we have our N-ethyl, and we're going to stick that in front of the ending here. So the name for this entire thing then would be N-ethyl. Tells us we have an ethyl group attached to the nitrogen. And then propanamide would be the last name for it. All right, so in a nutshell, that's your nomenclature for the amides. Amides are things that we see a lot in chemistry and biochemistry. Urea, for instance, is a molecule that contains the amide bond. It's the end product of when you metabolize or break down your proteins. And there's a host of conditions associated with the buildup of urea, for instance. You also find amides in several different drugs. So barbiturates are amides that have the functional group present in a ring or a cyclic structure. And these are commonly used as sedatives, or in larger doses they're used as sleep inducers. So for instance, phenobarbital or pentobarbital. If you look here closely, you can see your C double bond O, and there's an amide bond here. There's an amide bond on the other side. There's an amide bond down here. There's lots of amide bonds. They just happen to be in a ring structure. And if you look over on this side, there's an amide bond over here, an amide bond there, and another one right there. We also find amides in aspirin substitutes, right? So for instance, phenacetin or acetaminophen, right? Very common drugs, over-the-counter medications that you may take. There's your acetaminophen, used as a pain reliever. There's your amide bond right there, C double bond O, N. So those are some of the general characteristics of your amides. The next thing we're going to take a look at are some of the reactions that the amides can undergo, and these are going to look similar to what we saw the esters were able to undergo as well. So the main type of reaction here is going to be hydrolysis. And we saw hydrolysis before. Remember, hydrolysis means the breakdown or the splitting of a molecule with the help of water. And just as we saw with the esters, this can happen under acidic or basic conditions. And the products are going to be different in each case. So under acid hydrolysis, the products that we get here are going to be the carboxylic acid, the original carboxylic acid, and then we get the salt of some of ammonium. Right, so that's under acidic hydrolysis. Under basic hydrolysis, we're going to get the salt of the carboxylic acid, and then we get the original amine, or if it was ammonia that was used to make the amide in the first place. All right, so let's just recap that here. Let's rewrite that because it's important to know what the difference is. So amides, so under acidic hydrolysis, we end up making the original carboxylic acid, and the ammonium salt. And then under basic hydrolysis, we end up making the salt of the carboxylic acid, and the original amine, whether it was an amine or whether it was ammonia that was used to make the amide in the first place. All right, so let's take a look at a couple examples of these, and then we'll practice a couple of them as well. All right, so here we have our acid hydrolysis of this amide, and this is ethanomide or acetamide. We actually drew this before. All right, and again, you know, just as we saw with the esters, we're going to break that amide bond right after the carbonyl. So we're going to split it right down the middle. And then what's going to happen is we're now going to take the OH from our water, and we're going to stick it onto the carbon of the carbonyl. And then the remaining parts of our reagents, the H here from the water as well as the HCl, they are going to be attached to that nitrogen in a specific way to give us that ammonium salt. All right, so let's take that and see what happens. We're going to attach, like we said, that OH to the carbon of the carbonyl. All right, and then what we also get is we're going to get that H from the OH from the water molecule. There it is. And then we also get an H from HCl. And what that does is it actually introduces a positive charge here on the nitrogen. And then if we take that H plus from the HCl, we also get a Cl minus. Right, and that's what makes it a salt, the fact that it is charged, or it has opposing charges, which makes it an ionic compound. Right, and that's all that a salt is. It's just a fancy word, or not so fancy word, for an ionic compound. So we get the original carboxylic acid, which would be ethanoic acid, and we could tell that because there were two carbons, 1, 2, in our original thing, and then we have ammonium chloride as our salt, as the other product. That's under acidic hydrolysis of the amide. Under basic hydrolysis, we're going to need some sort of a base, which in this case, a strong base like sodium hydroxide or potassium hydroxide, for instance. All right, and again, we are going to break the amide bond right between the carbonyl and the nitrogen. All right, and then what we're going to do is we are going to attach the O and the Na to the carbon of the carbonyl, and then the H from the NaOH gets attached to that nitrogen of the amine. All right, so we stick in here the O minus and the Na plus to make it a salt now of that carboxylic acid. So we had a 1, 2, 3 carbon carboxylic acid. That would have been propanoic acid. And now we have the salt of it, the sodium salt. So it ends up being sodium propanoate, which we saw before in the esters chapter. And then when we stick that H onto our nitrogen, right? So here, there's that H that we stuck onto it. We just have our regular amine, which in this case is methylamine. All right, so we get the amine and we get the salt of the carboxylic acid. All right, so let's take a look at an example. And it says here, draw the structure for the products when N-methyl-pantanamide undergoes hydrolysis with NaOH. All right, so this tells us two things. We're looking at the basic hydrolysis. Okay, and what tells you that is, tells you hydrolysis, and then it's basic because we're dealing with NaOH of N-methyl-pantanamide. So let's just rewrite that, and then we can draw the structure out. So we have N-methyl-pantanamide. So let's draw this. We always start with the last name. So we have a pent something, so we have a 5-carbon amide. So there's our C double bond O. So that's 1, 2, 3, 4, 5. All right, and it's an amide, so we need to have a bond to nitrogen. That makes it the amide bond. And then on that nitrogen, we have a methyl group attached to it. All right, which is just a 1-carbon group. And then don't forget, nitrogen needs to have 3 bonds. So we have 1, 2, and then the third bond is going to be to hydrogen. All right, so you first of all need to draw the structure of the amide. Before now, we subject it to hydrolysis using sodium hydroxide. All right, so we're going to split this just like we did with the esters. We're going to split it right after the C double bond O. We're going to break it right there. And then under basic conditions, remember, we end up making the original amine. In order for that to happen, the H from the NaOH gets attached to that nitrogen. All right, so let's draw that amine. We have our N connected to our CH3. There's our H, so stuff that does not change, and the only thing that changes now, we're going to add that extra hydrogen onto it. All right, and then the other product here is going to be the salt of that carboxylic acid. All right, that's this portion. So let's draw everything that doesn't change. All right, so we have 1, 2, 3, 4, 5 carbons. 2, 3, 4, 5. Our C double bond O. And now what we're going to do is we're going to attach now that NaO to this carbon here of the carbonyl. All right, and in order to make it a salt, it's going to be the O minus, and then we're going to have that Na plus attached to it. All right, so we get our products here ends up being the amine, and we also get the salt of the carboxylic acid. And if we wanted to, we could name these, probably should. So this here would be methylamine. And then our salt here, the carboxylic acid, this would be sodium. And then we have a 1, 2, 3, 4, 5. So that would be Pantanamide would be the last name for that. All right, so hopefully what you're seeing here is, yes, there's a lot happening, but there are some similarities. There's actually a lot of similarities to what we saw back with the esters chapter in terms of not only how we make the amide, but also how we break it down under acidic or basic conditions. All right, let's finish up here by taking a quick look at some of how we draw some of the structures again. So let's look at the first one. We have Pantanamide. All right, so that means we have a 5-carbon amide. So let's draw that 1, 2, 3, 4, 5. C double bond O to N. That makes it the amide bond. We don't have anything else attached to that nitrogen because there isn't any N-ethyl or propyl or methyl or anything. So then this is just going to have the remaining bonds to H's to complete the fact that nitrogen needs to have 3 bonds. For N-ethyl, so again, start with the last name. All right, benzamide comes from benzoic acid. So we draw that skeletal structure first. So there would be our benzoic acid. We want to make it an amide, so we connect that to an N. That's our amide bond, and now it's telling us we have an ethyl group attached to nitrogen. That an ethyl is a 2-carbon group, so 1, 2. And then the remaining bond here is going to be to hydrogen, right? All the remaining bonds are going to be to H to give it enough bonds to give the nitrogen 3 bonds. All right, so that's the idea behind your amides. We're going to see amides a lot when we get to the protein chapter down the road. And just as a sort of as a preview, I'm just going to put this down here. The amide bond is also called a peptide bond. In biochemistry. All right, and we're going to see that a lot in proteins specifically. So when we get to that proteins chapter, we're going to see this exact same functional group, but we're going to call it by a different name. We're just going to call it a peptide bond. It's the exact same thing as an amide bond. All right, so don't get confused when you see that. You see that a lot actually in not only in chemistry but other sciences. There are different names that mean the same thing. All right, so peptide is the same as the amide bond.